Bismillah ar-Rahman ar-Rahim. Today I would like to talk about an interesting presentation about the ablation strategies for correction of different types of astigmatism. Please prepare your coffee and your calculator and let's dive in this interesting presentation. I would like to thank Dr. Ala about his continuous support. His great work and dedication is always inspire us. Visual impairment caused by astigmatism ranges from 2.2 to 34%, around 2.7 up to 2.5 million people suffering from astigmatism all over the world. I think about this presentation because if you have patient with relatively thin cornea, abnormal key readings, and uncommon high refraction error, you have to ask yourself some questions. In which meridian your laser machine will correct this type of refraction in order to calculate your ablation depth and keratometry changes. Here are two examples of two different types of astigmatism. On the left side is simple hyperopic astigmatism. On the right side is a compound hyperopic astigmatism. If you notice on the left side, you will see that the key readings are flat. The cornea is relatively thin, 499, and on the right side, the key readings is relatively steep according to this type of refraction, but with normal corneal thickness. This example, if you don't know how your machine will correct this type of refraction, maybe you will have doubt on doing such cases. Different type of refractive astigmatism are simple myopic, simple hyperopic, compound myopic, compound hyperopic, and mixed astigmatism. And here are some examples. The simplest way to know the type of refraction or the type of astigmatism is to change it or transpose to plus cylinder. Yani here as an example is simple myopic astigmatism. If you simple myopic astigmatism, no need to transpose it. It's very obvious. One meridian is plano, the other meridian is simple is myopic cylinder. And if you have مثلا this example اللي هو compound hyperopic astigmatism plus 4 minus 1, you have to, if you transpose it, it will be plus 3 plus 1 axis 93. So it's compound hyperopic astigmatism. And the same is in mixed astigmatism. If you transpose it, it will be minus 2 plus cylinder. So two different signs. So it is mixed astigmatism. One meridian myope, one meridian hypope. Different astigmatism ablation strategies: negative cylinder, positive cylinder, bitoric, and cross cylinder. Here, this diagram shows that a myopic cylinder work on flat meridian, including the central area, while a hyperopic cylinder act also on the flat meridian, but only work on the peripheral area to steepen the central area, but it doesn't work in the central area. The left side is the myopic ablation, the right side is the hyperopic cylindrical ablation. Here, the ablation depth of our laser machine while working in 7mm optical zone: -1 is 20, -2 is 39, -4 59, -3 59, -4 78. If you notice, if you focus about this number, you will not find linear progression between the diopters and the ablation depth. Means that in -2 is not 40, it's 39. While you go more for diopteric ablation, you will get less ablation depth. First example of this presentation is simple myopic astigmatism. Here is the planning software of our laser machine. I put this refraction 0 plano, -3 cylinder, axis 180. He showed me this diagram. The red color is the ablation, the areas of ablation, while a lighter colors are the areas where the ablation is less. I found that the central area is around 60, in the peripheral area in the around 60 also, the same amount. So I think the machine will work on that meridian with the same amount of refraction. Now, what is this meridian in this example? This meridian is a flat meridian, and here is the steep meridian according to the refraction. So I concluded from this map that a simple myopic astigmatism is ablating this refraction as it is upon the flat meridian. -3, it's working on this flat meridian. Why? To flatten the steep meridian, which is in 90 degrees. Here is the difference map between the stromal thickness pre-operative here, post-operative here, and here is the difference. This is the actual amount of ablation that our machine did. And here is the planning software. If you notice here in the central area is 60, peripheral area is 60, but actually what happened is 73 in the central area, which ablates more. So don't trust too much on your machine. You have to leave safety margin. Alhamdulillah, our machine almost always ablating less than the planning software, but sometimes it ablate more. So you have to take care. But why I took the stromal thickness map to exclude any changes in the epithelial map. Here, the same patient, but the changes in the keratometry. Here is the pre-op key readings, post-op key readings, axial curvature map, and here are the difference. And here is the planning software. The machine correct -3 on the flat meridian, which is 0, 180, to flatten the steep area, which is around 90. This is the amount of flattening happen on the steep meridian, -2, -2.3. According to compound myopic astigmatism, I did the same. I just entered disease refraction, -1, -3, axis 180. And we know previously, as mentioned before, -120, -239, -359, -4, 78. I found that the central area is around 78, which means 4 diopter ablated here. And the peripheral area 60, which is 3 diopter ablated here. But what happened? I concluded from this planning software that the machine ablates -3 cylinder on the flat meridian, 0, 180, and adding -1 on the central area. So all this meridian is -3, and the central area is -4, -1 plus -3. And here also a change on the stromal thickness map. If you notice here 77 in the central area as the planning software, will actual ablation 73, which is a little bit less than the planning ablation, our planned ablation. And here also is the changes on the key readings. The machine work on the flat meridian. Here work on this meridian, the flat meridian, to flatten the steep meridian, which would happen here -3, -4. Here is the amount of flattening. Right. According to simple hyperopic astigmatism, I just entered this type of refraction, +3, -3, axis 162. If you want to know this type, what is this type of astigmatism, transpose it to plus cylinder, so it will be 0 +3, 92. So it's simple hyperopic astigmatism. I found that all over this meridian is 0. The blue color means 0. Central ablation here is 0, and on the 162 there is ablation. 162 is the flat meridian. As we said before, myopic cylindrical ablation or hyperopic cylindrical ablation are working on the flat meridian. I found here is around 60, or here also is around 60, 64. This is small change because of something called coupling effect. So here is 3 diopters just ablated from this flat area, this peripheral area on the flat meridian. So I concluded that according to this planning software that the machine works this refraction as a plus cylinder. 0 sphere, so here is 0, here is 0, here is 0, here is 0, and the +3 work on the peripheral area on the flat meridian, 60, around 60 here, around 60 here. But is there another type of ablation may happen? Yes, let's take another example. A bitoric cylinder. But in bitoric cylinder, it's done on while you have 2 meridians astigmatic. But if you have one meridian is plano and the other meridian is hyperope or myope, it work as plus or minus cylinder. But I'm take assumption if the machine is ablating this refraction as a bitoric, just to understand the bitoric. Okay? But if you have a bitoric cylinder, it will be 0, axis 162, or +3, axis 72, according to this refraction. After I transpose it, I will show you later how you can get a bitoric cylinder. So, is 0, axis 162, according to this refraction, a flat meridian is what? Is around 70. 72 is 72. So it will ablate zero ablation in 72. This is happen here according to this software. And this refraction plus 3, 72. 72, a flat meridian according to this refraction is what? Is 162. So it ablates 3 diopters is 162. So I concluded also that according to this planning software, a simple hyperopic astigmatism may be corrected also as a bitoric cylinder. Okay? But as we said before, a bitoric cylinder it happens while you have two meridians are astigmatic. But in simple hyperopic astigmatism, one meridian plano and our emetrope, while other meridian is hyperopic ametrope. Okay? Right. Here an example on a change map on simple hyperopic astigmatism. Here is the amount of ablation. Well, here is thin cornea, the preoperative stromal thickness map. Relatively thin cornea, not a thin cornea, is a relatively thin cornea. Okay? Type. Here is the change on the key readings according to the axial map. It work on the flat meridian to step in the central area, but work peripheral here, to step in this central area. Here, what happened is here is the change in the steepening happening according to ablation. Okay? Type. According to compound hyperopic astigmatism, +4 -1. If you ablate it as a negative cylinder, it will be as it is. If you ablate it as positive cylinder, it will be +3 +1. Bitoric. How you get bitoric or double cylinder? After you transpose this refraction to plus cylinder, you will enter the first one in the sphere +3 and the reverse axis which is on 180. We here after algebraic summation of both of them, it will be +4. So and then this axis as it is. So you get bitoric ablation or calculation according to this method. If you want to get a cross cylinder, how you can get it? A cross cylinder, after also you transpose to plus cylinder, you will divide this equally to +half minus half, +half 90 minus half 180. And in the spherical equivalent between them, you will add it to, if it is a plus, you will add it to L plus. If it is negative, you will add it to the negative. Okay? But here is to calculate it at your clinic. But the machines always adding a coupling effect. I will not explain today. I will talk today about the coupling effect, but just to simple information. And here also is the change according to planning software. I entered this refraction +4 -1, axis 3. I found here is ablating around 66, whose central area is 0, whose peripheral is 87. Okay? 60 يعني around 3 diopter. وhere is around اللي هو 87 around 70 plus a coupling effect. Okay? Around 4 diopters. Around here 4 diopters. وhere 3 diopters. طب what happened? If we take this refraction, took this refraction and assume that the ablation is corrected as a plus cylinder will be +3 +1 axis 93. +1 axis 93, the flat meridian here according to the refraction is what? Is 180. يبقى 1 diopter will be ablated at this area, 1 diopter ablated at this area. With 3 diopters will ablate in all the optical zone, all around the optical zone. يعني 3 diopter here, 3 diopter here, and previously 1 diopter. So 3 diopter here in 90, 4 diopter is 0, 180. So I concluded from this software that this refraction, our compound hyperopic astigmatism, may be corrected as plus cylinder. طيب. I assume it corrected as a bitoric. Bitoric it will be +3 axis 3 +4 axis 93. +3 axis 3, what is the flat meridian according to +3 axis 3 is 93. So it work on the flat meridian low 93 diopter low around 66. +4, what is the flat meridian according to this refraction is what? 3. So it corrects 4 diopter in 3. So according to this planning software, may our machine correct a compound hyperopic astigmatism as bitoric cylinder with 0 ablation. Type. Assuming if you assume this refraction is corrected as a minus cylinder, never happen. Why? Because there is 0 ablation in central ablation. Type. cross cylinder, it may correct it as a cross cylinder. Cross cylinder is minus half, as we said before. Here is a cross cylinder, here minus half. Minus half is corrected in the center area, but here is the center area is 0. So according to this planning software, compound hyperopic astigmatism of our machine corrected as plus cylinder or bitoric cylinder. Here is the amount of change according to LQ readings on the axial map. Work on the flat meridian mainly to steepen the central area as it is. After that, the amount of the whole optical zone, peripheral optical zone, will be corrected as a plus 3. Right. According to a mixed astigmatism, I took this refraction plus 1, minus 3, 180, and here are the possible refraction if you want to correct as a negative cylinder, positive cylinder, bitoric, or cross cylinder. Right. I just entered this refraction plus 1, minus 3, 180. I found the central area 40, the peripheral area 60, and here is this meridian 90 is 0. Okay? In between is the transition zone. Type central area 40 maybe 2 diopter ablated in central area, 60 and 3 diopter ablated in the peripheral area on the flat meridian. So, if this machine, I assume this machine correct this refraction as negative cylinder. So negative cylinder minus 3, it will ablate 60 diopter all over the flat meridian, even in the central area. Which this is not happening. Central area is 40, not 60. So it doesn't correct it as minus cylinder. Type, assuming at positive cylinder, minus 2 plus 3. Plus 3 axis 90, it work on the flat meridian, lower 180, as we said before, you bet 60 diopter here, 60 diopter here. So it is 60 diopter. Minus 2 is corrected on myopic spherical aberration, minus 2 correct in the central area as this, يبقى 40. يبقى so according to this planning software, mixed astigmatism may be corrected as plus cylinder. Type, I took it bitoric minus 2, 180, plus 1, 90. Plus 1, 90, the flat meridian of 90 is what? Is 180. يبقى 1 diopter is ablated here, 1 diopter is around 20. Well, minus 2, 180, minus 2, 180, this is the flat meridian. Okay, this is meridian. So, يبقى 2 diopter here ablated as a myopic. Central area is minus 2 also, as we said before, in the minus cylinder work in the whole flat meridian. So, if you add 2 diopter, 1 diopter at the peripheral area of the flat meridian, so 3 diopter equal 60. We central area as a myopic cylinder اللي هو 40. So according to this planning software, mixed astigmatism may be corrected as a bitoric ablation. طيب, I took it cross cylinder. Cross cylinder plano plus 1.5 axis 90. يبقى axis 90 في البلس يبقى الفلات meridian is in 180. يبقى 1.5 will ablated here, 1.5 ablated here. 1.5 اللي هي around 30. Okay? We minus half minus 1.5, 180. So 1.5 will be ablated on the whole flat meridian. So 1.5 from hyperopia, 1.5 from myopia. So here 3 diopters around 60, and here is 60. We minus half will be around ablated in the central area, and there is also minus 1.5 on the central area. So the central area will be ablated by 2 diopters. And here is the change on the stromal thickness map according to mixed astigmatism, and here are the changes on the key readings. So why we don't use negative cylinder in compound and the mixed astigmatism cases anymore? Before, this has happened before, as it ablate more tissue in the central area who has a hyperopic shift, unlike the hyperopic cylinder has no or a little amount of myopic shift. Why the lasers machine are always working on a flat meridian? The cylindrical ablation, which flatten the steep meridian, has the characteristic of inducing hyperopic shift. If the machine work on the flat meridian, on the steep meridian directly, it will have a shift. But if it ablates the flat meridian, it indirectly work on the steep meridian with less tissue ablation or without affection on the hyperopic or myopic shift. Bitoric ablation in compound astigmatism, it work on both meridians. In mixed astigmatism, because you have hyperopic when positive and negative cylinder, work only on the flat meridian. While I'm discussing some point of this presentation with Dr. Ala, he's just gave me this Excel. He did it in the early 19s. You just put the refraction. It gives you a cross cylinder ablation and a bitoric ablation with coupling effect. Simple myopic astigmatism work at negative cylinder, compound myopic negative cylinder, simple hyperopic positive cylinder, compound hyperopic positive cylinder or bitoric will mix astigmatism, positive cylinder, bitoric and cross cylinder. Positive cylinder and the bitoric ablation are ablating less tissue than the cross cylinder and the negative cylinder, especially in the central area, while plus cylinder, bitoric, and the cross cylinder are the same ablation in cases of mixed astigmatism. Same calculation, same calculation. Mathematically, ablation profile of positive cylinder is almost like a bitoric and the cross cylinder in cases of mixed astigmatism. Thank you.